Welcome to Excel 2013 Statistical Analysis video number 50. Hey, if you want to download this Excel workbook, Business 210 Chapter 8, or our PDFs for Chapter 8, click on the link below the video. In this video, we have to talk about calculating confidence intervals when we don't know sigma. So what we said the last couple of videos is when sigma is known, which is not usually the case, but in some cases it is, we use the standard normal distribution with our z. But now, what do we do if sigma is not known? Well, we're going to use something called the t distribution. And there are many t distributions. Now, actually, that's a bad drawing here. Let's go ahead. Many t distributions. Here's the t distribution if our sample size is 100, 50, 30, or 15. Now, there's lots of t distributions, and each one is based on sample size n, or the parameter degrees of freedom, where we take the sample size minus the number of samples. Now, in this chapter, we only have one sample. Later, we'll see when we have two samples. This means that when creating our confidence interval, we have to choose the correct t distribution. So if we have n equals 50, we choose this one. N equals 50, degrees of freedom equals 49. If we have n equals 30, we choose this one. N equals 30, degrees of freedom equals 29. Now, in the old days, you had lots of tables, right? And you'd look them up. In Excel, there's the t functions, and we simply tell it degrees of freedom, or with Confidence.T, we tell it the n. And it will know which distribution to go to. Now I'm going to go 2 slides ahead. T distribution. It's also called the student's t distribution. We first need to think about when we're allowed to use the t distribution. You can use it when the population distribution is normal shaped or near normal, or n is sufficiently large, using the central limit theorem. Characteristics. Very similar to the z distribution. Continuous, normal or bell-shaped, and symmetrical. So that means we have that line down the middle, 0 for the t or the z, right? But in this case, it's t. 0.5 on this side, 0.5 on this side. All the area is 5. The symmetrical means 0.5 there, 0.5 there. The smaller the sample size or degrees of freedom, the larger the standard deviation and flatter the curve. So flat out here, you can see n equals 30, degrees of freedom equals 29. N equals 15, degrees of freedom 14. Much flatter right here in the middle and more spread out. The larger standard deviation, which would mean that the interval would tend to be much bigger if you had the same margin of error. Now, this makes sense, right? The smaller the n must make the interval bigger. 4, at the center, the t distribution is flatter and more spread out than the normal z distribution. So right down here, there's a little teeny drawing here. So you can see if we had our z distribution, 95% would give us about minus 1.96 standard deviation here, 1.96. If we had the same, if we had n equals 5 to get the same 95% confidence interval, we'd have to increase, or decrease as the matter may go on this side, from 1.96 to 2.76. So that means we're multiplying times the standard error, right? And we have a much bigger number, which means the value is much further down here, in order to get the same 95% probability or confidence interval. Finally, the 5th characteristic, as n, or degrees of freedom, increase, the t distribution approaches the z distribution. Above 100, they're almost the same. Now let's go to our next page here. Here's our formula for confidence intervals for estimating mu when sigma is not known. So our x bar plus or minus t sub alpha divided by 2 times, and we're going to have to use our sample standard deviation divided by n. This is all going to be the margin of error. That'll be our standard error. There are all of our variables defined. In Excel, we're definitely not going to use the norm functions. We're going to be using the t functions. Oh, so last video we used norm.inverse when we had the z distribution. Here, when we have the t distribution, we'll use t.inverse. Instead of confidence.norm for Z, we'll use confidence.T. And we have a great, awesome option for when you have sample data. We use the data analysis descriptive statistics, and it'll calculate X bar, S, and margin of error all automatically. So we'll see all three methods. Let's go over to Excel. Here's a little picture I made in Excel on the T sheet just to show the difference. OK, so degrees of freedom 9 and 99. Or if I change this to 5, you could see the smaller the n or degrees of freedom, the more spread out the distribution. All right, let's go over to the sheet, sigma not known. Now, this is our printer manufacturer example, and we're going to see all three methods here. So printer manufacturer is a manufacturer of computer printers and print cartridges. They would like to create an ad that says how many pages customer could expect from their cartridge. Something like a customer can expect an average of with a margin of error of. All right, so now we're using a small sample here. The assumption for the T distribution is that the population has to be bell-shaped or normal-shaped. And for something like a pages coming off a printer cartridge, or cereal boxes being filled, or human weight, all those things have a bell-shaped normal distribution. So we'll assume that population is normally distributed. Now, because it is such a small sample size, that'll affect which distribution we select. And the distribution, since the n in degrees of freedom is so small, will be more spread out. All right, let's go ahead and calculate our X bar. We'll use average to calculate our mean. Now, I want to actually round these because these are to the pages. You can see over here I have the round function. Now, the round, you can tell it to round to whichever digit you want. We want to the integer, so you put 0. 2,409. All right, standard deviation, STDEV.S. All right, so we're calculating. We don't have sigma, so we're calculating S. And I'm going to also round this. 0 means to the integer. So 304n, we need our n, count. We have numbers, so we're going to use count function. Numbers, the sample is 1, so we'll calculate our degrees of freedom. We can calculate our standard error using our S. So we'll take our S divided by square root of our n. Confidence level 0.95. Alpha, that's the risk, the population mean is not in our confidence interval. And alpha divided by 2. We need that for the upper end. Now, we're going to calculate T directly and then use our formula for calculating margin of error. T inverse is the function we'll use. Now, we want T on the upper end. That means all the probability except for this little bit on the upper end. So we do 1 minus this. And notice it needs the degrees of freedom, 9. OK, so we have 2.26 as our T. Now we can calculate our margin of error. We have our standard error times, and how many standard deviations do we want? We want 2.26 of them. So there's our 217. Now we could round this one too. I don't have the round over here. Round. And then we come to the end, comma, 0 to the integer. So 217 pages. Now here we calculate our margin of error in a few steps. We did the standard error, the T dot inverse, and then calculated our margin of error using those inputs. We could go directly and calculate margin of error using the CONFIDENCE.T. Now this is a great function. CONFIDENCE.T did not exist in earlier versions. Excel 2010 is the very first one. The inputs here, it wants alpha. So the whole alpha, or risk, comma, the standard deviation, it wants the S. And then the size, which is n. So if you forget that, there's a great trick here. You can click on this hot link here and open it up, and it goes to the help, and it will tell you. But on some of the other functions we saw, like norm.inverse, it says standard deviation, and it wants standard error. But here it actually wants the sample standard deviation. So you got to know those inputs. And if you look at my handwritten PDFs, I have notes on the inputs for all the functions right next to each other. So maybe that'll help. All right, so there's our margin of error. Why don't we do that little same bit? Round, comma, 0. So the confidence.T is a great new function that directly calculates margin of error. Now, either margin of error we use, we can say we have our sample mean minus, and then our sample mean plus, or whichever standard. So there we have 2,192 to 2,626. Now those are 1 and 2. Let's look at a great third method. And actually, the textbook only shows you method 3. Again, I might ask you for any of these. The T functions, the textbook doesn't even mention them in Chapter 8. In next chapter, Chapter 9, we'll do a hypothesis testing, and we'll do a bunch of T functions. In fact, in the PDFs, I show you these 3 methods I'm doing in this chapter. The very next sheet gives you a preview of all the T functions and how we won't use all of them until Chapter 9. All right, so let's look at method 3. Now, method 3 requires that on the data ribbon tab in the analysis group, you have the data analysis. If you don't have that added in, you missed one of the earlier videos. You have to right-click any ribbon, customize ribbon. And then you have to go to add-ins. We could have gone to options too. Add-ins. You have to come down here and say add-ins. You have to click go, and then you have to click the analysis tool pack. Escape, escape, escape. Absolutely awesome. Watch this. So what it's going to do is we're going to tell it this column of data here, and it'll calculate X bar, sample standard deviation, N, and it will give us margin of error. It's just totally amazing. It's not dynamic. Formulas are dynamic, right? So if you ever have, the reason lots of people do it this way is maybe their data is changing regularly, right? But this will give us a static, just to paste the numbers as it calculates it behind the scenes. So I'm going to click this. I'm going to go to Descriptive. I'm going to click OK. Input range. I'm going to highlight. There is a label at the top, so I'm going to say Labels in the first. It's in columns. Output range. Now notice when I click Output range, it jumps up here. I've gotten tricked by this many times. I'm going to be sure and click down here, and then pick like C23. Summary statistics, and here it is, confidence interval. And you can put whatever you want here, 90, 95, 96, 99, whatever. I'm going to put 99, and then click OK. And look at that. Oh, it even calculated the standard error. Look at that. Now our numbers, we rounded up here, so our numbers are going to be a little bit different. But you got to be kidding me. Is that totally beautiful? So we could then come down here, and we'll do lower limit, upper limit. And from this input data here, we say, hey, our mean minus our margin of error, and equals our mean plus our margin of error. All right, so when we get almost exactly the same values. Now, when you do we actually saw this feature, descriptive statistics, in earlier chapters when we were calculating median, mode, standard deviation, variance, and stuff. But notice confidence interval, if you put that in, it does the T distribution. So our conclusion would be a customer can expect, and we just plug it in here. It's 2,409 with a margin of error of 217 pages, right? So maybe we can put pages here. So a customer can expect an average of 1,400 pages with a margin of error of 217. So that was our first example of the T distribution. Let's go over to T2. Here's another example. So a restaurant magazine wants to rate a particular restaurant. They go out and ask 50 randomly selected customers to give a rating between 1 and 10 so they can estimate the population mean rating. So here's our data set here. We have n equals 50. Let's go ahead and count that. Counts numbers. We'll calculate the degrees of freedom. So we take our n minus the number of samples. Our x bar. 5.98. So that's the average rating. The standard deviation. DEV.S. Control-Shift down arrow. So 2.52. We'll calculate our standard error equals our s divided by square root of our n. All right, and we have a 95% confidence interval, so we'll say equals 1 minus. I guess all the examples I picked were 95. They're not always that way. 99 is common, 90 sometimes. All right, and then alpha divided by 2. All right, so we have our inputs, and then method 1, we can use our T-inverse, T.INV. We'll calculate the upper T, so equals T.INV. Probability, 1 minus alpha divided by 2. And the degrees of freedom. Remember, the T has to know which of the many distributions to go to. So degrees of freedom, that's the input. We'll say, I see I did the wrong formula there. Notice I didn't mind because I know this is a formula input, so I can go and change it, and boom. Margin of error, I'm going to say number of standard deviations times our standard error. That means we have our margin of error. We take our x bar, which is our rating minus that. X bar, our rating plus. So it looks like 5.3 to 6.7 would be a reasonable range for the population rating mean. Second method, our confidence.T. I love the new confidence.T. Alpha, that's the whole alpha. Standard deviation, that is the S. Comma, and the size, that's going to be our N. Notice how the confidence.T is asking for N, but our T-inverse wanted degrees of freedom. So you have to be careful with those. Oh, we get the same number, though, and then we simply add and subtract. Equals, there's our average rating, plus 0.7. You get the same exact thing, different methods. And then you got to love this one. We'll go up to data analysis. We'll select descriptive statistics, click OK. It's got the wrong range, so I'm going to click in A4, Control-Shift down arrow. Labels, yes. Column. Output range, definitely not correct. I'm going to click there and make sure it's C29, A4 to A54. OK, that's looking OK. Summary, confidence. I'm going to click OK. And I already had this down here. That was risky. Did that? Oh, yeah, I guess I did set it up just to barely fit. Now we have we can calculate our lower and upper limit. There's our mean from our descriptive statistics minus the margin of error. Notice it doesn't say margin of error, it just says confidence interval, but that is the margin of error. And so now we are 95% sure that the population mean for restaurant rating is between 5.3 and 11.2. What did I do wrong there? Oh, all right. Someone's triple checking. All right, so 95% sure that the pop mean for the restaurant rating is between 5.3 and 6.7. So that's a little bit about constructing confidence intervals when we do not know population standard deviation sigma. We use the T distribution. And we saw two examples of the T inverse, the confidence.T and the data analysis descriptive statistics. All right, in our next video, we'll talk about estimating an interval for proportion, a population proportion. All right, see you next video.